Okay, good morning everyone, especially to our professor, Sir Al. So I am the presenter today. I am Rolando Crustipa from Ipil, Zamboanga, Sibugay. So my topic today will be glaciers, types, movements, and causes. So our learning objectives are as follows. So identify the different types of glaciers, describe their characteristics, and they explain their formation, and recognize the importance of glaciers in shaping landscapes and influencing global climate patterns. So to start with, what are glaciers? Glaciers are made up of fallen snow that over many years compresses into large, thickened ice masses. Glaciers form when snow remains in one location long enough to transform into ice. What makes glaciers unique is their ability to move. Due to sheer mass, glaciers flow like very slow rivers. Glaciers formation, so it started from glacier ice formation, granular snow, the fern, the glacier ice. So that how the glacier form. So let us proceed to growth of glaciers. So we have here the accumulation, the ablation, and the terminus or the terminal point where the calving of icebergs is being formed. So glaciers grow or recede as a function of the balance between accumulation and ablation of snow and ice. The accumulation zone is a region where snowpack or superimposed ice accumulation persists. The ablation zone is the region where all of the snow has melted away and where glacier ice is exposed. Crevasses in glaciers. So as you see here, there are three forms: the compression crevasses closed, the tension crevasses open, and brittle zone. So crevasses are common in the upper parts of the glaciers when the ice is subjected to tension. So we have also the structure of glaciers. Sorry. The region near the head of the glacier where snow is converted to firn and then ice is called the zone of accumulation. The region near the foot of the glacier is called the zone of ablation. This is where the ice is lost by melting, evaporation, or calving to make icebergs. So separating the accumulation zone from the ablation zone is the equilibrium line. The equilibrium is the location at the equilibrium line altitude. So this is a valley glacier, zone of accumulation. This is now the equilibrium in the middle line, zone of ablation after that. So below the bedrock. Then we have the definition of glacial erosion. So what is glacial erosion? Abrasion, it is a grinding of surface. Glacial flour, silky powder that develops as glaciers ground down rocks and pebbles under them. So we have also glacial striations, grooves and striations caused by rock fragments. Flocking, water freezes and cracks rocks and these rock fragments and carried by the glacial ice. So this is now the illustration: the blocking, the ice flow, the glacier abrasion. So we have also the glacial landforms. The landforms created by glacial erosion are cirques, arites, paternoster lakes, U-shaped valleys or glacial troughs, tarn, hanging valleys, and horn. So this is also the illustration of the terms that I have been mentioned. Next is the depositional features. So in the depositional features, there are different moraine. So the moraine features made of till. So lateral moraine, till collected on valley sides by rock falls and plucking of valley walls. Then we have also medial moraine formed by merging of lateral moraines as two glaciers meet. Then outwash plain, region in front of a melting glacier, typical, typically has braided streams. Terminal moraine deposited at the farthest point of glacial advance. Then we have the till, unsorted sediment deposited directly by glaciers, and ground moraine. This is the blanket of till left by melting glacier. So here are the illustration of lateral moraine, the medial moraines, and end moraines. So the terminus of glacier, recessional moraine, ground moraine, and terminal moraine. So you can refer to this illustration. Okay, let's move. Where are they located? So as you see, the middle line is where the equator is located, and the upper and the lower portion, the Arctic, those are the Arctic circles. So we have here the upper portion of the Arctic Circle, we have the Greenland, and upper portion of the equator, we have the Himalayan, and below we have the Patagonia. So distribution of glaciers in the world. So these are the regions and the area in kilometer square. So we have here Africa, 10 kilometer square. So Antarctica we have also here. You can just refer the numbers, that is self-explanatory. So Asia and Eastern Europe, Australia, the Europe, the Western, the Greenland, North America, South America. Then there are primary two types of glaciers, the alpine glaciers and the continental ice sheet glaciers. So under the alpine glaciers, we have also five: the cirque glaciers, valley glaciers, ice caps, Piedmont glaciers, tidewater glaciers. So let us define first what is alpine glaciers. The glaciers in mountain that flow down valley is called alpine glaciers. So we have here the picture of the two samples of alpine glaciers. So we have also the different parts of the alpine glaciers. The Piedmont glacier, when two or more glaciers meet and merge at the base of mountains. So the new glacier is called the Piedmont glacier. So we have here the example. The two glaciers merge at the center of the mountain. So we have also the tidewater glacier. If the Piedmont glacier flows to the sea, it's called a tidewater glacier. So we have also here the example. Then let us proceed to the next form of alpine glacier, which is the cirque glacier. The glacier confined by a valley forms in a cirque or semicircular basin at head of valley, formed by plucking of bedrock by glacier movement or moving downward. So this is also the illustration of the cirques or the circular basin glacier. Then we have also the valley glacier. Valley glacier confined to a valley usually formed from streams. So I think you can really understand the illustration. This is self-explanatory. So let us proceed to the next. We have also the ice caps. So an ice cap is an ice mass that covers less than 50,000 kilometers square of land area, usually covering a highland area. Larger ice masses covering more than 50,000 kilometers square are termed ice sheets. Then we have also the other form of glacier, the continental ice sheet. The continental ice sheet, largest of glaciers that cover thousands of square kilometers, found only in Greenland and Antarctica. So that is greater than ice caps. So glacier movement. How do the glacier move? So These are the explanation how they move. So the fundamental cause of ice movement is gravity. So glaciers flow downslope because they accumulate mass, or what we call ice, in their upper portions from the precipitation and from wind blown snow and ability, or what we call the melt, sublimate, and calm icebergs in their lower portions. As the ice in the accumulation zone builds up over time, the weight of it builds up a downslope pressure known as shear stress. This increases as the slope angle increases, and once it is greater than the resisting forces, the glacier moves downward. Okay, so let's continue. This forward movement continues regardless of whether the glacier is advancing or retreating, as in below. We have here several illustrations, so you can refer this one. Zone of accumulation, as seen in the illustration, we have the equilibrium line. Then the zone of ablation, this is the melting point. Then the next illustration, the more snow, so the lower equilibrium still, then less ablation, the advance, and this is also the less snow, still the higher equilibrium line, then the terminus wherein the retreat is found. Next is, we have here the warm base glacier and polar glacier. So when we talk about warm base glacier, moved by basal slip and internal deformation. So as you see, we have here the arrows. So the first arrow, basal slip glacier can slide because ice melts under pressure, resulting in a form of water acting as a lubricant. So we have also the creep and rigidation, or the enhanced basal creep is best for causing ice to deform around large debris deposits such as boulders. So rigidation slip is the process of melting and refreezing of ice over small deposits. So we have also another extensional and compressional flow over steep slopes. Basal sliding increases and ice accelerates and thins. Okay, extensional over shallow slopes, basal slip slows and ice thickens. This is the compressional flow. So we have also here the polar glacier. So move only by internal deformation. So the weight of the glacier causes ice crystals to deform. So the glacier moves slowly down slope, or individual layers of glacier move forward. So it is still fall under warm base glacier. And we have also the surge. Glaciers can advance up to 100 times their normal rates. They are usually caused by enhanced basal creep due to a build up of meltwater at the ice rock interface. So this is the example. Okay, let us proceed.
The sheet of ice that covers Greenland contains enough frozen water to raise oceans by 25 feet across the globe. As the planet warms, glaciers melt, causing sea levels to rise. But not all of that melt happens at the surface. In the summertime, rivers and pools of meltwater find their way down through the glacier to the bed below. From there, the water runs beneath the glacier until it reaches the ocean. Because meltwater contains no salt, it weighs less than ocean water and rises up the front of the glacier in what scientists call a plume. Around Greenland, oceans are cold and fresh near the surface and warm and salty at depth. As the plume rises, it draws in the warm, salty water, melting the glacier face from the bottom up. Eventually, a piece of the glacier breaks off, making an iceberg in a process known as calving. As the oceans warm, Calving speeds up, causing glaciers to retreat and flow faster. Faster glaciers dump more ice into the oceans and drive sea levels higher across the globe.
Okay, so I think the video can support some of the ideas to explain how the retreat and advance glaciers occur. So let us continue. We have here also the glacier ice motion. So warm base, cold base. So the video also explain about the how the warm base and the cold base moves or occur. So another example, or we have also here the internal deformation. The ice under stress from movement deforms. This is called ice creep. That results from the ice thickness increases or changes in slope angle. Where the ice creep can't respond quick enough, ice faulting occurs, which can create crevice-like features of the surface. So when the gradient increases will give us an equal to glacier accelerates, causing ice faulting extensional flow. So decrease gradient, decrease acceleration of ice causing the ice to compress, which leads to faulting in the ice where crevices close up. So we have also here the extensional and a compressional flow. So as you see, so the white on the top of the yellow, which is the bedrocks, the portion of the bedrock. So we have here the snow. So extending flow. So the verge run or crevice at a glacier head and crevices. Extending flow crevices and seracs, ice blocks or step fall. You have also here the compressing the flow. Then the crevasses. So valley rock basin, we have the rock step or bar with ice fall. Then the cirque rock basin. So base of the rock. So that is for the extensional. For the crevices, transverse crevices, we have to know transverse and the longitudinal crevices. For the transverse crevices, form across a glacier in a region where the speed is increasing, which causes its stretching in the direction of glacier flow. The fan across the glacier, common in the accumulation zone and near steepening slopes. Longitudinal crevices are parallel to flow form in the direction of a glacier flow and where ice slowly spreads out sideways to cover a larger area, commonly found near the terminus of a glacier. So the illustration below will gives us an idea of the transverse crevices and the longitudinal crevices. So the lines can describe the directions of the different crevices. So here are another example of the crevices. We have the transverse crevices. Okay, we have also velocity of glacier ice. So overall warmer glaciers move faster than colder ones due to basal sliding and internal deformation. Even greater speeds can be achieved when the glacier moves over deformable sediment. There are a number of factors that can impact you upon the rate of movements. We have the altitude, the slope, and lithology, size, and mass balance. So I think that is a self-explanatory. It is understandable based on the given ideas. So let us proceed. We have also subglacial bed deformation. When a glacier moves over relatively weak or unconsolidated rock and the sediment itself deforms under the weight of the glacier moving, it is called subglacial bed deformation. Locally, this can account for up to 90% of forward ice movement. So further, help and glacial movement can be found in this video. So I haven't sent the video, so you can just click this one because I don't have my internet stable internet connection as of this moment. So how does it affect life on Earth? So glacier melting water provides many regions with fresh drinking water. They create homes, ecosystems, and habitats for many organisms in our animal kingdom. The meltwater, aka rundown of glacier water, provides energy resources to certain countries. They provide water to desert regions. Next is glaciers are also a natural resource, and people also over the world use the melted water that glaciers produce. Then people living in an arid climates near mountains often rely on glacial melt for their water for part of the year. So farmers have also irrigated their crops for hundreds of years by channeling melted water from glaciers to their fields. Okay, we have also glaciers are being threatened every day. Are we aware of this? That we are one of the contributing factor of the global warming, which is one of the most threatening issues that we are facing today. So the biggest threat to glaciers is global warming. Global warming is melting our glaciers, creating sea levels to rise dramatically. So what will happen if there is an abrupt rising of water due to the melting of glaciers? So melting glaciers also means that the habitants will lose their home and way of life, creating tragedy in ecosystem across the world. So I think this is really informative, and because of this topic, I know how to mitigate, to produce, or to become one of the contributory factor for the increase of the greenhouse gases. So let us continue. Many regions will lose their fresh water source. Many regions near the oceans and seas will become flooded and non-existent. So maybe this will come into tragedy if there would be an abrupt arising of water. So let us continue. What are some solutions? So we have also some solution. So since we have discussed that there are problems or threatening to our environment, we have also several solutions for us to survive. So find energy resources that do not produce greenhouse gases. Then contribute to the cause of eliminating greenhouse gases by monitoring your personal carbon footprints. Then corporations should adopt environmental ethics and promote and implement better measures to reduce greenhouse gases. Then people should look into alternate energy resources that do emit greenhouse gases into the atmosphere, such as solar and turbine energy. So these are some of the solutions, and I would like also to add um, something that can help um, our environment in choosing of the refrigerator. Example, when we buy a refrigerator, let us look for a non-CFCs refrigerator. So CFCs stands for chlorofluorocarbons. So this chemical, it is one of the contributory factors. It has a great greenhouse gases contributions. So can cause to global warming. So chlorofluorocarbons. So that is how we are going to buy our appliances and or even aircon, a refrigerator. So as long as there is a prion, let us look for the non-CFCs product. Okay, so let us continue. So I have here the research trends. The title of this is The Structures and the Formation in Glaciers and Ice Sheets. Authors Stephen J. A. Jennings, and Michael J. Humphrey. The first published 27th day July 2021. So we have also here the link. If you can look for the complete um, um, research paper, because in my research trends, I just get the abstract of this paper. So the aims of this review are to describe and interpret structures in valley glaciers in relation to strain history, and to explore how these structures inform our understanding of the kinematics of large ice masses and a wide range of other aspects of glaciology. Structures and glaciers give insight as to how ice deforms at the microscopic and larger scale. Structures also provide information concerning the deformation history of ice masses over centuries and millennia. From a geological perspective, glaciers can be considered to be models of rock deformation, but with rates of change that are measurable on a human time scale. However, structural assemblage in glaciers are commonly complex, and unraveling them to determine the deformation history is challenging. It thus requires the approach of the structural geologists. So a wide range of structures are present in valley glaciers. Primary structures include sedimentary stratification and various veins. Secondary structures that are the result of brittle and ductile deformation include crevasses, faults, crevasse traces, foliation, folds, and uh, boudinage structures. Some of these structures, notably crevasses, relate well to measure strain rates, but to explain ductile structures, analysis of cumulative strain is required. Some structures occur in a glaciers irrespective of size, and they are therefore recognizable in ice streams and ice shelves. Structural approaches have wide but as yet underdeveloped potential application to other subdisciplines of glaciology, notably glacier hydrology, debris entertainment and transfer, landform development, microbiological investigations, and in the interpretation of glacier-like feature on Mars. Okay, so for my first topic, I would like to thank you for being awake. Okay, and then I have still another topic. It is all about dessert. So I will be uh, playing my screencast on the other video. Okay, so let us continue with another topic about desserts. So our objectives are as follows. Number one, identify the different types of dessert. Analyze the unique characteristic of deserts, including their climate, flora, fauna, and geological features. And of course, our third objective is recognize the ecological importance of deserts in daily life. So, to start with, what is a desert? How many types of deserts are there? What are the unique characteristics of desert? So, this will be answered by the following explanation.
Welcome to Moo Math and Science. In this video, you will learn about the biome called desert. Although most people think of the Earth's deserts as wasteland, there is a large number of animals and plants that have adapted to the harsh conditions of a desert. In fact, 1/6 of the Earth's population live in desert regions. But what is a desert? Deserts cover more than 1/5 of the Earth's land, and they are found on every continent. A place that receives less than 10 inches or 25 centimeters of rain per year is considered a desert. If you take a look at this map of the Earth, you can locate areas that are deserts. The Sahara Desert is here. The Gobi Desert is found here. Arctic Polar, the Great Victorian, to name a few. Many deserts are dry and hot, but there are cold deserts as well. The Sahara Desert in northern Africa is the largest hot desert in the world and reaches temperatures up to 122 degrees Fahrenheit or 50 degrees Celsius during the day. But some deserts are cold, like the Gobi Desert in Asia and the desert on the continent of Antarctica. Desert animals have adapted ways to help either keep them cool and use less water. For example, camels can go for days without food and water. Many desert animals are nocturnal, coming out to hunt only at night in order to avoid the sun. Some animals, like this tortoise, will spend much of their time underground in a burrow. Other desert animals have adaptations to help keep them warm and survive in cold temperatures. This polar bear has thick layers of fat and fur for insulation against the cold, and the white appearance is helpful for camouflage. The snowshoe hare has white fur in the winter and reddish-brown fur in the summer, which means it is camouflaged from its predators for most of the year. Desert plants may have to go without water for long periods of time. Several plants have adapted by growing long roots that reach the water table underground. Other plants, like cacti, conserve water in order to stay alive. Plants in cold deserts grow close to the ground and close together, which helps resist the effects of cold weather and to reduce damage caused by snow and ice particles driven by the cold winds. Some plants, like lichens, can survive on bare rock. Plants and animals in hot deserts have to survive extreme heat. Death Valley holds the record for the hottest temperature ever recorded at 134.06 degrees Fahrenheit. Plants and animals in cold deserts have to survive extreme cold. Average temperature of the Arctic Polar Desert is negative 30 degrees Fahrenheit in the winter. So there we go, a look at our biome called desert. Thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe and share.
Okay, thank you so much. So for that video, I do believe that it summarizes already my topic. My part now, I am just giving you a more detail when it comes to the different types of desert in biomes or desert biomes. So deserts are arid or dry environment where there is less than 250 millimeter of rainfall annually. So deserts occur where evaporation is greater than precipitation, or where precipitation is less than 250 millimeters a year. These areas cover about 30% of the Earth's surface. Some of the world's deserts are hot and others are cold. All, however, are dry. So we have here the cold and the hot. So global distribution of desert biomes. So we can see, so the red line at the middle, that is the equator, and the upper portion, the North Pole, the 30-degree north and the 30-degree south below. So desert biomes are generally around a belt of 30-degree north and south latitude. Types of desert. The world's deserts are often classified according to the amount of precipitation they receive. We have here the classification: extremely arid, so amount of precipitation, no precipitation for 12 consecutive months or 1 year. Then we have also the arid, less than 250 millimeters of precipitation per year, and we have semi-arid, between 250 millimeters and 500 millimeters of precipitation per year. Desert types: we have subtropical, coastal, cold deserts, and polar deserts. So for the subtropical, a climate is warm or hot and dry year-round. This region receive an annual rainfall between 30 to 65 centimeter and occurs mostly during the summer monsoon season. Temperatures during summer may rise to 40 degrees Celsius. The climate is pleasant between October and March, hotter between April and June. Monsoon rains occur in most regions in summer between June and September. On the other side, we have also the the coastal. These have cool winters and warm summer. A coastal desert, the Atacama of South America, is the Earth's driest desert. So we have also here the cold deserts. So these deserts have long dry summers and low rainfall in winter, generally found in the Antarctic regions. They have short, moist, and moderately warm summers with fairly long cold winters. Example of this is Gobi Desert. Another, we have also desert type, the polar deserts. Climate is cold year-round. In polar deserts, snow domes occur commonly in areas where precipitation is more abundant. An example of this is Antarctica. So, to be more detailed, hot deserts generally lie around the Tropic of Cancer or the Tropic of Capricorn. So, the upper portion of the equator, that will be the Tropic of Cancer, and the lower portion to the south, that is the Tropic of Capricorn. So they have very hot summers and warm winters. Temperature extremes are common as cloud cover is rare and humidity is very low. This means there is nothing to block the heat of the sun during the day or prevent its loss at night. Temperatures can range between around 45 degrees and negative 15 degrees Celsius at 24 periods. So, we have also the cold deserts, lie on high ground, generally north of the Tropic of Cancer and south of the Tropic of Capricorn. So, the upper portion of each tropic. They include the polar deserts. Any precipitation falls as snow. Winters are very cold and often windy. Summers are dry and mild to warm. So here are the formations of the detailed informations about the hot desert and the cold deserts. So the blue, it is the cold, and the red is the hot deserts. So we have Turkestan, Gobi, Takla, then the hot deserts we have Sahara, Arabian, Kalahari, okay, Namib, Australia, and so on and so forth. So these are the list of the deserts in the country where they belong, and this is the land area in kilometers square. So you can read that one, and I think that is self-explanatory. So let us proceed. So by the way, I have here what we call the length for the purpose or length for the games of, let us say, if you are going to discuss this in our class, these are what we call the lengths that we can get some of the games or simulation games, interactive games, which is very effective in teaching. So you can use this application link rather, https www.purposegame.com/game/11 So this site, you can get some of the interactive games as what I said earlier. So you can try it if you have time. So you can just type what topic you would like to have. Then you will be given different types of games as you wish. So to continue, where are deserts located? Where are they located? So cold Asian currents exist of the western sides of continents. Winds blowing over these currents lose their moisture over the sea and are dry by the time they get to land. In the interior of continents, winds blowing over continents are dry by the time they get into the interior of continents. So location of deserts, depressions, basins in the interior of continents, the surrounding highlands around depressions or basins cause a rain shadow effect, leaving the depression dry. So we have also the location of deserts, the leeward side of tall mountains. Moisture carrying winds are blocked by the side or windward side of tall mountains. The other side, leeward side, is consequently dry and the deserts may be formed there. So we have here deserts where and why. As you see, the green color, the strong green color at the middle, that is the equator. So we have to take note that nearest to the equator is the hot, or what we call the hot desert. And above of the equator, we can find the cold deserts. Okay, let us continue. I have here an example. Australia, apart from Antarctica, Australia is the driest continent in the world. About 35% of the continent receives so little rain, it is effectively desert. In total, 70% of the mainland receives less than 500 millimeter of rain annually, which classes it as arid or semi-arid. So, orographic rainfall we have here. So, the leeward portion, which is the color red, then the windward portion is on the color blue. So, how do they work? Okay, the air mass now or snow drier flows down the leeward side of the mountains. So the downward, the rainfall occurs on the windward side of the mountain. This is the process of how the wind transferred from one medium to another medium. So warm moist air approaches a mountain barrier. So the color light blue. What's that light blue? Then the air mass is forced to rise as it hits the mountain and condenses into clouds. So as you see below, the dry air mass becomes warmer with little chance of rain. Deserts are often found on the leeward side of large mountain ranges. So here we have another example. So the arrow now, if we are going to follow the arrow, so we have the mountain range. So warm moist air cools as it rises. Okay, because in this portion, precipitation will take place openly. But when it reaches to the peak of the mountain and it goes down, cold dry air warms as it descends. So warm dry air. So this is where the deserts found. Okay, I think you can understand by following that arrow. So deserts characteristics. So we have climate, animals, plants, seasons, adaptations, significance to human. So let's start with the climate. The desert is the hottest biomes on earth. It also has the extremes. It can be over 100 degrees during the day and below 32 degrees at night. Less than 25 centimeter or rainfall every year. The amount of rainfall varies, but when it rains, it pours. After the storm, the desert may not see any rain for weeks or months. So the animals that can adapt the temperature, we have also here the snakes, owls, mice, armadillo, lizards, finnick, foxes, gila, monsters, bats, and vultures. So the climate, we have also the climate. What causes deserts? So air masses found 30-degree north and south of the equator move in circular patterns. So we have here the diagram by Hadley cells. So as you see that the arrow is the arrow coming from both ends pointing to the equator. So in Hadley cell, air rises at the equator. As it rises, it cools, causing the moisture to condense and precipitate, leaving the air dry. The dry air descends around 30-degree north and south of the equator. In areas where the air descends, a high pressure zone is created. Winds blow outwards from the high pressure areas, so no moisture can be brought in by the wind. Therefore, there are very low precipitation levels, hence the location of many deserts are found there. So still, saka seasonal variation, we have also diurnal or daily variation. So the summer months temperature ranges are between 30 to 49 degrees Celsius. Very little or no precipitation occurs during the summer months, and evaporation rates after exceed precipitation. So during the winter months, temperatures are lower around 10 to 20 degrees Celsius. Most of the annual precipitation occurs during this month. So during as a diurnal, temperature exhibit daily extremes because the atmosphere contains little humidity to block the sun's rays. So during the day, the sun's energy is absorbed on the ground surface, which heats the surrounding air. At night, the reverse happens. The hot ground and air radiates the heat energy gained during the day back out to space, causing the rapid temperature drop. Night temperature can reach below 0 degrees Celsius. So we have here also the soil. Occasionally, when a lot of rainfall occurs in a short space of time, very little of the water is infiltrated into the soil as it is very hard and dry. Therefore, there is high surface runoff. Okay. So this is what really happening today in our case in Ipil and in Titay. So many farmers were affected of this El Nino. So extreme heat. So they cannot able to plant the rice field due to loss of water, or even the irrigated rice field, they cannot able to support for the whole farm. So these are one of the reasons or the effects of the global warming. So let us continue. What are the plants that can adapt with this kind of climate? So we have here the xerophytes and bryophytes. So are plants that have adapted to arid environments by storing as much of the little water made available and reducing evapotranspiration rates. So cacti is an example. I think the video already explained this one. So other common adaptations, reduction of leaves. So in order to survive, open into spines for protection against animals trying to consume the stored water. Okay. Then we have also the development of the stem as the major photosynthetic structure. With leaves reduced, photosynthesis has to occur somewhere. So water storage and the steam water is needed for many things. If the plant is to have it available, it must be stored. Development of defense structures, spines, but chemical defenses are also very common. With less photosynthesis taking place, growth of desert plants is often very slow, and under these conditions, it is advantageous for the plants to make greater investments in defense. So coating the plant with a thick waxy cuticle, this helps reduce water loss. So a dense coating of hairs, trichomes, so this slow air moving over the surface of the plant. Since the air in the desert is very dry, any air movement tends to increase evaporation. The trichomes create a microlayer of humid air around the plant, particularly in the vicinity of the stomata. So extensive underground root also we have here. These roots can either grow straight down to the groundwater if it is available or spread out extensively under the surface of the desert. The latter growth, okay, form allows the plant to take advantage of the short what we call it, the short intermittent rains. So the key and the strategy is the elimination of the competitors' roots. Many desert plants inject toxic chemicals into the soil to kill their competitors' roots. So animal adaptations, we have also different animals that can adapt. So it was explained by the video. Okay, 2 rows of long eyelashes protect against blowing sun and sun. Keep out blowing sun. The nostrils can be closed. Okay, so thick fur and under wall provide warm during cold desert nights and insulation against daytime heat. Then fat stored in hams help it to survive long periods without food and water. Then broad flat leathery pads at the bottom of their hooves. Pads spread out when the camel places its feet on the ground, thus creating a snowshoe effect and preventing the camel from sinking into the sand. So animal another the picnic packs adaptation, burrowing the nocturnal lifestyle. So during day. So function cooler temperatures at night mean less water loss while carrying out activities. So large ears help dissipate excess body heat on hot days in the desert. So thick sandy fur helps insulate them from the cold desert nights but also reflects heat as well as providing excellent camouflage. Okay, we have also another common animal adaptation, panting to reduce body heat, secreting high concentrated urine, seasonal migration, long-term dormancy that ends only when triggered by moisture and temperature condition. So let us now proceed to the human impact. This is the most important of my topic. So we humans are the contributors of the global warming. Whether we like it or not, some of our co-endeavors are doing such thing which is unhealthy to our environment. So here are some of the human impacts that maybe we do this without thinking about the future generation. So let us be uh, positive, let us be decisive in making decisions, especially to our young generations if they have uh, something to harvest later on. So we will have our development today without compromising our future generations. We have this development of cities. So it is good for our modernization and globalization. It is good for our economy. However, it gives us other side effects. And we have also oil drilling, irrigation, interference of natural ecosystem, agriculture, settlements, and pollutions. So dito talaga pollutions, we are, I think we are the most uh, contributor, the best contributors of pollution. Okay, so if you have the human impact, let us continue. So human impact, deserts are also being destroyed by development. Do you agree? I think you will agree with me. As populations in desert cities rise, so does the demand for water. So many desert streams and groundwater sources once used by animals have been drained for industries, agriculture, and people. So this is the human impact. So maybe the government should have the this what we call the strategy to implement the law in order that people will follow. So maybe I can say, in my own opinion, um, on the previous administration, the presidency under Rodrigo Duterte has great power in implementing rules and laws, especially in cleaning the Manila Bay. And I do believe that everybody is aware that the Manila Bay today is now a park. From polluted water becomes the nice place or a tourist place. So there is something to do with the government to implement, kung baga, what should I say, kamay na bakal in implementing the law. So yun. So this would be the impact, the human impact. So with this topic, I have here also the research trend. So this is entitled Study of Changes in the Ulan-Bo Desert under the Dual Impact of Desert Farmland Development and Climate Change. So I forgot to write the author. I'm sorry for that. I have written the abstract or copy paste the abstract. The desert farmland provides food for desert areas, but water is the main limiting factor of this region. Thus, farmland has an extremely fragile ecological environment. This study investigates the temporal and spatial variations of vegetation, or NDVI, normalized difference vegetation index, in the Ulan-Bu Desert, China from 1990 to 2022 using long-term Landsat satellite data obtained from the Google Earth Engine platform and local statistical data. So the results showed that from 1990 to 2022, the NDVI exhibit relatively small fluctuations and a steady increase. Furthermore, the study analyzed the impact of climate factors, namely precipitation and temperature, on NDVI, and collected the groundwater level changes under irrigation and farmland development. The results demonstrated a positive correlation between NDVI and both precipitation and temperature from 1990 to 2006. The study area experienced an overall trend of increasing humidity. Especially from 1990 to 2006, significant positive correlations with precipitation and temperature were observed in 4.4% and 5.5% of the region respectively. From 2007 to 2022, significant positive correlation were observed in 5.4% and 72.8% of the region for precipitation and temperature respectively. This finding suggests that temperature has become increasingly influential on vegetation in the VI. So while the impact of precipitation remains relatively stable, moreover, the study assesses the impact of human activities on vegetation in the VI. The results revealed that from 1990 to 2006, human activities contribute to 43.4% of the promotion of local vegetation, which increased to 90.9% from 2007 to 2022. This study provides valuable insights into the dynamics of vegetation in the Ulan-Bu Desert and its response to climate change and human activities. The findings highlight the significance of climate condition and human interventions in shaping the vegetation dynamics in the region, offering essential information for ecological restoration and conservation efforts. So conclusions, in 2023, the frequency of sandstorms in the Ulan-Bu Deserts continues to increase. Our objective is to uncover the key environmental changes occurring in this region. This study provides an in-depth analysis of the changes in NDVI and its influencing factors, while also examining the future trends of NDVI and the impact of human activities. The Ulan-Bu Deserts are unique deserts with contrasting features. On one hand, they are characterized by extremely dry and meteorological conditions, leading to the frequent sandstorm. On the other hand, their location, long along the Yellow River has allowed them to benefit from extensive irrigation through the Yellow River water projects. Consequently, large areas of farmland have been developed, making this region an